Hello and welcome everyone. In this video I'll discuss about the shapes of different atomic orbitals starting from S till D. Well, to understand the shapes of the atomic orbitals, let's begin with the orbital quantum values. For L equals 0, 1, 2, 3, 4 and 5, we have the corresponding orbitals S, P, D, F, G and H. This video is restricted to the shapes of S, P and D orbitals. For a given L value, there are two L plus 1 M sub L values ranging from plus L up to minus L with a difference of plus or minus 1 since these are quantized values. So for L equals 0, the ML values are only 1 and that is 0, and for L equals 1 the ML values are 3 ranging from plus 1 till minus 1, and for L value 2 ML values are 5, altogether it is plus 2 till minus 2. Well, that looks like a pyramid. For L equals 0, the different values for angular momentum is only 1 and that value is 0, which indicates S orbital, which is spherical in shape. It's a non-directional orbital. For L equals 1, the allowed values are 0 and plus or minus 1, where 0 correspond to pz orbital and plus or minus 1 correspond to either px or py orbital. The shape of any p orbital is a dumbbell with two lobes having opposite phases of wave function, that's pz, px and py. Shape is dumbbell. Let me represent these orbitals in three-dimensional space defined by x, y and z coordinates. This is for S orbital that has a spherical in shape, which is a non-directional orbital. Later on we have p orbitals starting with px having two lobes along x axis with different signs of the wave function, one lobe towards you and one lobe away from you. For py orbitals, the two lobes are along the y axis, one towards your right and one towards your left. And for pz orbital, there are again two lobes, one above and one below with opposite signs of the wave function. Well, all the three p orbitals do not have center of inversion as it is found here. That's the structures of p orbitals dumbbell shapes. For L equal to 2, the allowed values are 0, plus or minus 1 and plus or minus 2. 0 correspond to dz square, plus or minus 1 correspond to dxz or dyz, and plus or minus 2 correspond for dxy and dx square minus y square. These orbitals are represented here. I'm just trying to show these orbitals. All the 5d orbitals are represented together. Let me move it much closer to have a better look. Well, let's name them. This is dxz, dyz, dz square, dxy, and the last one being dx square minus y square. Well, dz square is having a single dumbbell shape where the two lobes along z axis is a dumbbell and the wave function along xy plane looks like a ring or a donut shape. The remaining 4 orbitals have double dumbbell shape. Now let me show you the planes in which these orbitals exist. dxz in xz plane, dyz in yz plane, dxy and dx square minus y square, both of them lying in xy plane. For dz square, the wave function is present. Yeah. Now here I'll represent for dz square. The wave function is present along xy plane, and also there is electron density along the z axis. So these are the two lobes along the z axis. Now let me represent these d orbitals. X, y and z spatial coordinates. Each of the d orbital has 4 lobes excepting the dz square. Well, here I have represented 2 lobes along the z axis, and there is also electron density along xy plane, which represents the dz square orbital. The next one being the dxz orbital. This is the plane. Now let me show you the lobes. The 2 lobes face the viewers and the other 2 lobes are away from the viewer. To say simply, it is like writing an alphabet X along xz plane. If you can imagine an alphabet X, and just imagine that you are writing the alphabet X along the xz plane, that is what represent the dxz orbital. Well, these are the other 2 lobes. Next, coming to the dyz, the 4 lobes are present along the yz plane that has been shown here. These are the 2 lobes having same phase. It is writing X along the yz plane. Just imagine writing X. Well, these are the other 2 lobes having a different sign. The next one being dxy, present in xy plane. It is visualized as X written along xy plane. These are the 2 lobes having center of inversion with same sign. Now let me take the other 2 lobes of same sign. On the whole, every d orbital contains center of inversion. So according to parity, every d orbital is gyroid. Well, that's an X. Now for dx square minus y square, which is also present along the xy plane, you just imagine writing a plus sign along the xy plane. If you can just imagine plus along the xy plane, that will represent the dx square minus y square orbital. This is also having the 4 lobes. Remember that imagination and creativity are key to chemistry. Right, so these are the 4 lobes. Now once let us look at the planes of these orbitals. Well, I am removing the orbitals and you can just see the planes that are present. For dz square, there is also electron density along z axis. Finally, coming to dz square, it is a combination of 2 orbitals, dz square minus x square and dz square minus y square. It is like 2 plus signs, one along xz and another along yz plane. Well, all of these are different orbitals and their shapes. Thank you.